Paul mentioned, my name is Bethany Abbate. I'm our manager for AI policy at the Software and Information Industry Association. And I'm joined by two esteemed panelists, Ellison-Anne Williams, the CEO and founder of Enveil, and Simeon Bochev, the CEO and co-founder of the Compute Exchange. So far in the program today, we heard what the US government is doing diplomatically in this area from Jennifer Baucus. We just heard a lot of really interesting perspectives from the previous panel and different concerns from different stakeholders. You are both founders of innovative startups that in some ways provide tools for organizations of all types that are trying to manage the risks around data localization. So we wanted to bring you together today for this last section of the program to hear about the perspective that you and your companies can bring to this discussion and the policy conversations around this as well. I want to start with you, Ellison-Anne, and talk a little bit about Enveil. Enveil is known for its zero reveal capabilities, which allows data to be securely and efficiently leveraged across silos and boundaries. Zero reveal leverages privacy-enhancing technologies, or known as PETs, such as homomorphic encryption and secure multi-party computation. Can you tell us a little bit more about this and maybe give us some examples for those of us in the room who don't have a PhD in mathematics such as you?
Yes, we'll leave the equations out of it. So privacy-enhancing technologies are a family of technologies that ensure the usage of data. And like Bethany said, they enable data to be used where it is, as it is, across all kinds of boundaries and all kinds of silos. And when we talk about using data, we really mean the place where you're extracting those insights that should yield value for the organization. So that includes searches, that includes analytics, and also this tool that we are focused on today, AI, right? So kind of how does this work from an AI or machine learning perspective? So the unit of work for AI is called the machine learning model. And as we all know very well now, but has always been the case, machine learning models encode the data over which they were trained. So if that data has any sensitivity to it whatsoever, then essentially sending that model out to be used, whether that's evaluation inference to get those insights out or further trained, is essentially the same thing as taking that sensitive training data, moving it out of that training location across the boundary and across that silo. Clearly, from what we've heard today, that's a huge, huge problem. Whether your boundaries and silos are things like operating jurisdictions that are driven by regulatory requirements, data sovereignty, localization, things like that. So what privacy-enhancing technologies can do is take that sensitive model that's been trained over that sensitive data, encrypt it within the trusted vault, and then send it out across those boundaries and silos so that it can be run in those places without ever decrypting at any point during processing. So if you never decrypt the model when it's being run for inference or training, then you never get to see the model. If you can't see the model, you can't pull any of that sensitive data out of the model over which it had been trained, nor can you kind of fool the model to get it to learn to make the decisions you want it to make, or make the incorrect decisions like model spoofing or data poisoning. So it really cuts off some of those more sophisticated adversarial kind of machine learning attack vectors. So the beautiful thing about privacy-enhancing technologies is that the security enables the business to use these sensitive machine learning models in ways and places they could have never done before to get value out of them.
Great. And how can this capability be more of a bridge rather than a barrier in the context of digital trade?
So, of course, AI machine learning models are only as good as the data that you're training or using them over. You don't get any better than that. And of course, we heard a little bit earlier that really to compete globally, you need to use all available data assets that you can. And that's globally, that's internally, that's across jurisdictions, all of those kind of boundaries and silos that we talked about. So what privacy-enhancing technologies uniquely enable from that model-centric security perspective is this have your cake and eat it too kind of dynamic, where now you can use these models across all of those boundaries and silos. You can make them smart. You can go run them to get insights in a secure and private way. So I think they're the key enabler when the rubber starts meeting the road to mitigate the risk associated with global AI workflows.
Thank you. And Simeon, the Compute Exchange is the world's first open exchange for GPUs and other forms of compute resources, addressing the needs of both buyers and sellers. What role does this model play in democratizing AI access and fostering AI innovation globally?
Yeah, definitely. And what we say at the Compute Exchange is our mission is to democratize intelligence, right, which is the output of the AI stack and the AI system. And if we think of AI today, I like to say that AI is actually killing innovation. And I know that that sounds a little provocative. What I mean by that is not AI itself, but the way that we deploy AI today. And specifically, it's three things. It's the incredibly high cost of AI systems, from the chips to the data to the models, the lack of capacity that exists in the world of those things, and then the high level of control that very few, largely American companies have over the entire AI stack. And those three things taken together make compute in particular highly heterogeneous, right? For those that know a bit more about the technology, an H100 chip that comes off the TSMC line and goes to our friends at Google is different than the same exact chip that goes to our friends at Amazon or at Microsoft or at many of the neoclouds. But it doesn't have to be that way. And so what Compute Exchange is really pushing for are, and I heard a lot of folks in the previous panel talk about standards, right? We're pushing for access to compute to not be the gating factor. Access should be open. It should be the value-add services on top of that that is where competition happens. And so we're adding radical transparency. I think, Shane, you mentioned we love competition, right? We do too. And we think that markets are Darwinian by their very nature, which means that if we can actually create a true market for compute, it means that there'll be a lot more competition, and I think America will favor very, very well in that.
Yeah, and can you dive a little deeper or give some examples about how this more dynamic and interoperable compute marketplace can really reshape the way digital trade and hence the broader AI ecosystem is approached?
For sure. So just some data. Today, we estimate that the compute economy is roughly $500 billion to $1 trillion per year globally. We think it's going to vastly eclipse the oil and gas market, which today is a $3 to $4 trillion per year market. We think that by 2030, it could easily be $5 trillion, and at steady state, $10 trillion or more. But today, that market doesn't exist, right? It's kind of hidden behind these artificial barriers that don't necessarily need to be there. And so what we're doing are a few things. We're driving radical transparency so that you can actually do an apples-to-apples comparison of what does this compute spec with this particular provider look like versus a similar sounding compute spec with a different provider. The second thing we're doing is radical price transparency. Why should supposedly the same thing cost $10 over here and $1.50 over here? I don't know another market where you can have almost a 10x pricing difference and that be okay. And then the third one, as I mentioned, is compute standards. And so we're working with Enveil, and we'll be launching and announcing at the end of this month what we're calling the Compute Standards Council. And I'd encourage anyone who's here and who mentioned in the previous panel that they're interested in supporting interoperable global standards to give me a call, because we're putting together this group to do similar things like what TCP/IP did, right? And enabled the internet to proliferate globally, but, Jennifer, with the American interest in mind.
Wonderful. Switching gears a little bit, Ellison-Anne, there's a degree of tension between enabling cross-border data flows with the need to also balance national security or regulatory compliance considerations. What role do privacy-enhancing technologies play in resolving this tension and in really enhancing security?
Yeah, as I mentioned before, I think the kind of beautiful thing about privacy-enhancing technologies is that they allow this kind of have your cake and eat it too in terms of getting value out of data across all of those kinds of situations that you just mentioned. And this is certainly true from an AI perspective, but there's a whole kind of ecosystem when you start looking at AI workflows and tooling. And I think it's easier for people to see it sometimes from a search standpoint. So, for example, if I am a global banking organization and I'm banking an entity in Singapore and I want to know, is my Singaporean entity being banked anywhere else in my own bank, because perhaps I'm watching it for questionable activity relating to financial crime or fraud? That's a really easy question and a reasonable one for us to want to ask. It's a very difficult one to get the answer to in practice, because just by asking the question to the UK, to Turkey, to Switzerland, are you banking the Singaporean entity, you're exposing Singaporean information outside of Singapore, which can be highly problematic. But where privacy-enhancing technologies come in is you can take that question for are you banking the Singaporean entity, you can encrypt it in Singapore in the form of an encrypted search, and then you can send that encrypted search out to all of the other operating jurisdictions of the bank. it can process out there without ever being decrypted, so no Singaporean information is ever revealed outside of Singapore. You get your encrypted results back in a matter of seconds, where you can decrypt and say, wait a second, the Singaporean entity that I had no idea was being banked anywhere else in my own bank is actually being banked in the UK. I should take auxiliary action. Exactly the same thing is true with AI and machine learning. It's just easier to see it for us from a search standpoint.
Great. From your perspective at the Compute Exchange, anything you want to add about how this enhances security or minimizes tensions?
For sure. So before being at the Compute Exchange, I was one of the leaders of AI infrastructure at Apple, where I think to one of the points made by the previous panel, you can solve a lot of data sovereignty issues without the data necessarily needing to be localized. And at Apple, that was a major concern of ours, right? And I think that when we look at compute today, what's really difficult, and I experienced this firsthand at Apple and continuing to do so at Compute Exchange, it's incredibly difficult technically to understand the actual differences between the different offerings that these providers are putting out into the world, right? And in many cases, they're framing it based on a type of chip as opposed to an entire holistic stack of solutions. And I think we fundamentally need to change how that works, and that's what we're doing. And so by doing so, I think it actually makes it better for everybody in the sense that you know exactly what it is that you're going to get. If you have particularly higher requirements than, let's say, the average person, then it's a lot more efficient to match you to the few providers in the world that can actually meet that need than have you spend literally months of time in a procurement process where you're talking to 30 vendors, of which at the end of the day, only maybe 3 or 4 of them can meet what you need, but you don't know that until you've gone through that months-long process.
Mm-hmm. And how do you see compute marketplaces really shaping the next decade of AI development? And what are the broader implications for these national competitiveness conversations that we're having?
Right. So, when DeepSeek came out, everyone was quoting Satya Nadella about Jevons paradox, right? The one that, the economic model that I particularly like is one where if you want to proliferate a particular product, and let's call that product today intelligence, right, the output of AI, then you want to commoditize the complements of that product. And so to take a step back, right, if we think back to, because many people compare, the nuclear arms race during World War II to AI today, if you think back to the 1940s, a computer fit inside of a hangar building, and the only people that could afford it were really the governments of the world, in particular the US government. Today, we all have micro devices on our wrists, but that wasn't necessarily going to be the case, right? What happened? IBM helped commoditize the cost of computer hardware down to something that makes it incredibly affordable to all of us. Apple, Linux, and Microsoft helped lower the cost of the operating system, right, and standardize it. And then we had open protocols like TCP/IP, the internet, that enabled the interconnection or interoperability of those different computers to thrive. All of that's missing in compute today. And so 10 years from now, if they're still missing, then we will have failed at our mission and our job.
Great. These are great examples from both of you so far, which makes it really tangible for I think, all of us to really understand. Last question, as we consider the concept of a globally interoperable AI ecosystem, as everyone is thinking about, what are the most important ingredients you would each say, whether technological, regulatory, or market-based, for enabling trust and collaboration across borders? And how do your respective business models contribute to that broader vision?
So one of the ways that I love to describe privacy-enhancing technologies is that they engineer trust. So when I gave you that slightly more detailed technical example around how you can encrypt these ML models and kind of run them across the boundaries and silos and cut off some of that adversarial machine learning attack vectors like model spoofing and data poisoning, et cetera, which is, by the way, why Gartner's included them in the AI Trust Risk Security Management Guide as a best practice, and you see that kind of globally echoed, including in the last White House AI executive order, then that situation enables that kind of trust and integrity in the workflows, because if I can run them and I can trust that now my machine learning models are making the decisions that they should be making based on the data, that they're learning to make those decisions that they should be making based on the data, now I can really use them fully for my benefit.
Great.
And I would say that similar to the previous panel, there's regulatory interoperability, but then there's also technical interoperability. And most of what I've talked about in the few minutes we've been up here has been technical interoperability. And I think that in the policy discussions, I haven't seen so much emphasis on that. But I think that without a focus on technical interoperability, you can try and regulate whatever you want, but it's not going to have the impact or the outcome that you're hoping it does. But then from a regulatory standpoint, I largely agree with what Shane was saying before, which is that you often in Europe see Europe regulating on input and not on output. But I don't think the answer is no regulation. I don't think that's what Shane was saying either. But what I do see in the United States is anti-competitive behavior from some of these large companies, and we see that with the Justice Department's actions in the last administration and the current administration. That to me, actually, that is at the crux of part of the issue. And a startup like mine is not going to solve that. We can't solve that. We do need regulators to come in and make it a level playing field, because it isn't today. If you look at, I like to say that 80% of the compute outside of China is controlled largely by 3 or 4 companies. That's it, right? 4 companies control 80% of global compute. How is that a level playing field? A lot could be said the same about data, although I know it less, right? And then when you look at the actual spend that's going on in the world towards AI systems, 10 companies, 9 of which are in the United States, account for 80% of the spend. So yes, we're in a race, and right now it's hyper-concentrated to a tiny, tiny sliver of the market.
Great. Any last-minute takeaways you want to share with the audience to wrap up our program? We have a couple minutes left, but otherwise, that's all the questions I had.
Yeah, I think this idea that we're somehow going to break down all these barriers and these silos around data through policy, through regulation, through legislation is not realistic. We're really in the era of hyper-localization. Those silos are getting more and more. The walls are going higher, things like that. We can certainly work to try to cooperate and pull them down as much as we possibly can. However, there is technology out there that allows the data to be used across them and still respect the reasons those silos were put in place at the beginning. So there is an ability to do both.
I would say in the last few minutes we have here that my 3 main takeaways for the group are: 1, if you're still waffling between are we in an AI bubble, is it all going to come crashing down? No, we're not. Now, maybe certain elements of the market exhibit a bubble, but we have drastically not enough capacity in the world today of compute. And when we hear about $500 billion for Stargate, when we hear about hundreds of billions of dollars, up to multiple trillions of dollars coming out of the Trump administration's Middle East trip, and then you hear skepticism of, is this all going to evaporate? I fundamentally believe that we are still very early. We don't have nearly enough capacity of what we need. We don't have nearly enough power to power those data centers in that capacity. And we need more investment, not less. So that's the first. I think the second, maybe to beat a dead horse around this interoperability, is we need those standards much sooner now than there's been an effort to put them together. I've heard a lot of talk starting at the Global AI Summit that happened, I believe, in the UK a year or 2 ago under the previous administration. But I haven't seen action, which is why we're taking action to put this group together to do it across the AI stack. And then I'd say third is we do need some amount of sensible regulation to help make it a level playing field. I think Europe in many cases takes it too far. The lack of a national AI data law in the US is the opposite problem. And I think I'm hoping that some of the folks in this room will address that latter point.
Wonderful. Well, thank you both for being here, and thank you for everyone who stuck around for the entire program. This concludes our event, but we will be out and about around here if you want to chat with any of us. So thank you so much.